Hey guys, in this question we are given a circle which is circumscribed by a quadrilateral ABCD in such a way that the sides AB, BC, CD and DA touch the circle at the points P, Q, R and S respectively. We need to prove that the AB plus CD equals to BC plus DA, that is the sum of opposite sides of the quadrilateral is equals to the other pair of opposite sides. So since the each vertex, that is A, B, C, D, has a tangent to the circle, and we know that the tangent from the common point to a circle are equal in length. So we can say that AP, that is this line, is equals to AS, and BP, that is this, is equals to BQ, and similarly CR equals to CQ, and DR equals to DS. So if we add all the right hand sides and left hand sides, that is AP plus BP plus CR plus DR, then we get it is equals to AS plus BQ plus CQ plus DS, and AP plus BP is nothing but AB, and CR plus DR is nothing but CD. Similarly, AS plus BQ is nothing but AD, and CQ plus DS is nothing but BC.